looking at linear systems, the first thing that we need to look at is solving linear systems graphically. Now, this is something that you would have done last year, but we're just going to review it quickly. There's really three ways that we'll solve linear systems, the first being graphically. But first, we need to know what it means to actually solve a system of equations. What that means is we were to look at these two equations here. Like looking at those equations, we need to find some point, now an ordered pair x, y, that satisfies both of those equations. When it satisfies both of those equations, well, what that means is that if we were to do a left side, right side check for both of those equations, it would work in both cases. And that means that the point is actually on both of those lines. It's where those points intersect. So when we're solving a linear system, we're actually finding the point of intersection. So if we look at this, we've got is 1, 2 a solution for the system of equations above. So we're going to check both of the equations and we're going to do a left side, right side check. So we've got the left side here. Now remember, this is x, y. So I'm going to just sub in 2 times 1 plus 3 times 2. That's going to be, I'm going to write out the steps, 2 plus 6, so that's 8. And then we've got our right side is also equal to 8. So therefore, left side equals right side, and therefore 1, 2 is a solution. So it works for the first equation. Let's check the second one. We're going to do the same thing. Left side first, so we've got 5 times 1. Minus 2 times 2, we get 5 minus 4, we get 1. We do the right side is also 1, so therefore our left side equals our right side. 1, 2 is a solution again. And that tells us, therefore, 1, 2 is the solution, is a solution for this system. Okay, now a lot of times when you're doing these, you won't have to put a therefore statement, but it is good to have that as part of your habits when you're going through these questions. Okay, when we're doing a check, the only way you can check a question is left side, right side. Now, whether that means that you're doing it like I've done it here, or if you're setting up some sort of left side and then doing the left side of the equation here, right side and doing the right side here and working down, you can never go across the equal sign. So you never want to have something like 2 times 2 plus 3 equals 4 minus 2 and then have 2 times 2 and then equals 4 minus 2 minus 3. Okay, that's not proper form. You'll lose marks for doing that. Okay, so when we're solving by graphing, this is the first way we're going to do it. 3 steps. Graph the equations. Now we can either graph using table of values intercepts or slope y-intercept, all of which we've looked at already. We're going to determine the points of the intersection. Okay, and then we're going to check by subbing into the equation. Now, we don't always have to check, but we can check if we have the equations. Okay, so if we look at this first set here, okay, so find the solutions by drawing both on this graph. Okay, so what we're going to do is I'm going to look at the equations. We've got 3x plus 2y equals 18. Now for this one, let's solve using x and y intercepts. Okay, so we're going to graph using x and y intercepts. So our x-intercept, we're going to let y equal 0. Now you could solve graph any way you want. I'm just trying to do it multiple different ways. So we're going to get 3x equals 18, and then x equals 6. And then our y-intercept, we're going to have it's kind of a sideways let there, but that's okay. X equals 0, so then we get 2y equals 18, y equals 9. So now I can put those on the graph. X equals 6, y equals 9. Now, if we look at that, we've gone down 9 and over 6, so that would mean we're going down 3 over 2. I can throw some other dots on there. Now I'm just doing that to make sure my line's pretty straight because I'm not drawing it with a ruler. So we've got that first line. Now we'll change colors for our next graph. So our second graph, we had x minus y equals 1. And now I'm going to rearrange this equation. And I'm going to make it y equals. Now I'm moving the y over to the other side. So I'll actually do this in a couple steps. I'll get x minus 1 equals y. Now that's the same thing as writing y equals x minus 1. I often get students getting confused by moving that over, but those are the same things. 2 equals 2 times 1 or 2 times 1 equals 2 are the same thing. So when we look at it this way, we have a slope of 1. We have a y-intercept of negative 1. So we're going to start at negative 1. And we're just going to go up 1 over 1. So that's just a diagonal line going through. Okay. And so we find that our point of intersection is going to be 4, 3. We go over 4, up 3. Okay, now if you looked at this equation though, this actually gave us a situation. So the path of 2 asteroids are given by the following equations. At what coordinates will the asteroids collide? Solve this graphically. Well, we found them. The point of intersection is right there. So therefore, the asteroids will collide at 4, 3. You always need to go back and read the question to make sure you're answering what it asks. All of that work that I did was great. I need to answer what the question's asking.